All right, so this is the second day for parabolas. So we'll start with this example F, putting the equations in standard form and graphing these. I'm actually going to do one before we do this equation. You can either write it down or just kind of follow along. The numbers for this one are a little bit tricky, so I'm going to give you one that's a little bit nicer first. So if you start off with just an extra example. If we start with the equation 2x squared minus 12x plus y plus 19 equals 0. So we know this is the equation of a parabola because you only see one term that's square, just the x has a square, the y doesn't have a square. So we're going to put this in standard form, and then we could go through and graph this. So to put it in standard form, I want the y's by itself, so I'm going to leave the y and the plus 19 on this left-hand side, and I'm going to move the 2x squared and the 12x to the right-hand side. And then in order to complete the square, the coefficient for x squared has to be a positive 1. So we're just going to factor a negative 2 out of both of these terms. And if I factor a negative 2 out of that 12x, I'm going to have a minus 6x. All right, so I haven't changed the value of it, I just did a little factoring on the right side. And then we're going to complete the square. So the number that's going to complete the square is going to be half this middle term's coefficient and square it. So half of negative 6 is 3, and 3 squared is 9. But you have to be careful because it's not really a 9, it's a 9 times that negative 2 outside. So really you just added a negative 18 to that right-hand side. So if I want to keep this balanced, I have to add a negative 18 to the left-hand side. So if I simplify it, I'm right back where I started. So on the left-hand side, if I combine, I'll have y plus 1. On the right-hand side, if I factor this, I'll have x minus 3 squared. And then I can get the y by itself. So the vertex then would be at 3, negative 1. And I know that the parabola opens downward because of that negative 2 out in front here. And then I would do the same thing I've done with the other problems there. I would pick a number, that's the vertex. I would pick, since it's x that's squared, not y that's squared, I pick a number that's bigger than 3 and smaller than 3, like 4, like 2, and plug it back into this equation to get my y coordinates. So if I plug in 4, I'm going to have 4 minus 3, which is 1. 1 squared is 1. Negative 2 times 1 would be negative 2. Minus 1 would be negative 3. Now if I plug in 2, I'm going to do the same thing. It would be 2 minus 3, which would be negative 1 squared, which is 1. So negative 2 minus 1 would give me negative 3. And then we could graph that. So my vertex is at 3, negative 1. Opens downward. So 4, negative 3 is another point that's on the parabola, and 2, negative 3. And you can see the parabola opens down. It's a little bit narrower because of that negative 2 out in front. So I gave you that one first because those numbers are nicer than what we have in example F. So we'll go back and we'll do example F now. And if you graphed this on top of this axis here, we can squeeze F in somewhere else then. So I'm going to erase this. So if you need to pause the video, pause the video. All right, so now let's do this one that we have here. So for this one, I'm going to get the y squareds together. And I'm going to put the 6x and the 13 on the other side there. All right, so if I complete the square, half of 2 would be 1. 1 squared is 1. I didn't have to factor that coefficient out in front like I did for the other one. Since I added 1 to the left side, I'm going to add 1 to the right side. And I can factor that left-hand side. Right-hand side, if I combine some like terms together there, I'll have 6x minus 12. And then I want the x by itself. You want the linear term by itself. The thing that's squared is going to have all the other stuff with it. So if I add 12 to both sides, and then divide both sides by 6, this would be 1/6, y minus 1 squared, and 12 divided by 6 would give me 2. Here's my equation in standard form. Like I said, we have that coefficient out in front that's a little bit trickier there. So my vertex then is going to be at my h comma k. Well, h is that number by itself there. K is always with that y. So 2 comma 1 is my vertex. Since it's a y squared, it's going to open either left or right. And since it's a positive 1, 6, it's going to open to the right. So again, if you pick values for, I'm just going to do this sideways just so it fits on the graph here. If I pick numbers for y that are bigger and smaller than 1, so a number like, I could put in 0, but if you look at the equation there, that's going to give me a pretty ugly number to work with. I'll have 1, 6 plus 2, which is going to be a pretty small number there. So I'm going to pick a number for y that's going to be something that I can divide by 6. So I'm going to pick a number like, if I put 7 in there, 7 minus 1 is going to give me 6. 6 squared is 36. 36 times 1, 6 will give me 6. And 6 plus 2 is 8. So that was kind of a nice number to put in there. You don't have to. You can pick anything you like there. But that kind of makes it work out a little bit nicer. And then if I pick a number that's on the other side of that, so numbers smaller than 1 there. So if I pick a number like, let's see, if I pick negative 5, negative 5 minus 1 would give me negative 6 squared, which is 36, times the 1, 6 gives me 6, and 6 plus 2 would be 8. So those two values worked out pretty nicely. And remember, since it's y squared, it's the y values that you're picking on either side there. So we can plot these points, 2, 1. That's my vertex. X is 8, y is 7. And then what do I have? 8, negative 5. So 8. We said it was going to open to the right. There it is with that vertex back there. So sometimes you get some fractions out in front like that, make it a little bit trickier there. So, so you'll see some problems like that in the homework. And then the last couple of homework problems that you don't have any examples in the notes for this. So this you may want to write down as well. So here's another bonus example for you. So if I give you points that are on the parabola, so if I tell you the vertex is at 1, 2, and I tell you you have a point that's on the curve, say at 3, 5, and they give you the diagram for it. So that's the vertex. So you can tell which direction it's opening, up, down, or left, or right. So if they give you this diagram and they say come up with the equation, go back to that standard form of the equation. Well, I know it's got to be y equals and something squared in terms of x because it opens upward. So that standard form of the equation looks like y equals a, x minus h quantity squared plus k. Well, I already know the h and the k values. The h and the k values are the coordinates for the vertex. I also know y and x values. They're the coordinates for this point. So I can take those values and plug them in the equation. The only value I don't know is a, so we'll figure that out. So my y value is 5, my x value is 3, my h value is 1, and my k value is 2. And then we'll simplify. So 5 is, 2 squared is 4, so 4a plus 2, and I can subtract that 2, so I'll have 3 is my 4a. So a is 3/4. Sometimes you get a fraction, sometimes not. And then they want the equation of this parabola. So we'll go back to y equals, take out a and replace what we found it to be, which is 3/4, x minus our h value, which is 1, quantity squared, plus our k value, which is 2. So that's the equation. You don't have to graph it because they gave you the graph for it. The last couple problems are like that. All right.